as I alluded to last time, just because a reaction will happen, that is, it's spontaneous, it has a negative change in potential energy, doesn't tell you anything about how fast it will happen. If you want to understand how fast a reaction happens, you have to understand something about energy and how that can be used to make a reaction happen. That is the idea of activation energy. So I want to talk about that now in this next little bit. Thanks to the folks at the Colorado University, we're going to be looking at a particular chemical reaction, a reaction of A reacting with the molecule BC and displacing it so that you end up with AB and C. So it's A plus BC goes to AB plus C. And we're going to look at how that reaction happens. We're given that this reaction is spontaneous. That is, it's favorable and there's a negative change in potential energy. So it can happen, but the question is, will it? What does it require? That is, in order to make this reaction happen, you've got to start forming a bond between A and B while you start breaking a bond between B and C. And that takes some energy input to break that BC bond. And that energy is in the form of activation energy. And so we'll do a little demonstration in a second to show what that actually means in practice. So here is the simulation. That's molecule A down there, which you can now shoot at molecule BC. And there's that BC bond between them. And the gadget at the bottom allows you to shoot molecule A at them with varying speeds, varying amounts of energy, and let's see what happens. So let's first try a small amount of energy. So we'll hit this, a small amount of energy, it's moving slowly. They hit, there's no reaction. We still have A and BC. Not enough energy to break that BC bond to make that reaction actually happen. So this has been no reaction, not enough energy yet. Let's try again with a little bit more energy. See if we can get enough to break that BC bond and get a reaction. Boom, no, still not quite enough to break that bond and get the reaction happen. So we're still back with the original starting things, A and BC. And they're just sort of bouncing around. Let's try a lot more energy. Crank it all the way up and see what we can get here. And here you can see, when you let it go, that bang, you've got the reaction. Now you see AB have formed a bond and C has been kicked out. There's the AB bond and C has been kicked out. So you had enough energy to make the reaction happen, to break that first bond, and then now the reaction has happened. Let's try it one more time just to show you what happens. So you hit it good and hard, and that A is going to come wailing in there, boom, and break the BC bond, and now you have an AB bond and C, and you've gotten to products. So that situation, you had enough energy. So the question for the next part is, how can you tell whether a situation is going to have enough energy to react or not? How you know whether molecules have enough energy to overcome that activation energy, if they have enough energy to react. And that's what the next bits are going to be about.